Hello everyone, today I will going to show the pile design. Before the going to showing the pile design, I want to notice that pile it is the similar to the column design, but practically we have followed the group provision. We will not follow this type of calculation. Rather, we will use this type of group provision in a practical fit, which is the minimum requirement steel bar for casting sheet of pipe. I will show you this, but I want to showing the hand calculation of the pile. So let's see the pile design. Here is the question: the pier of the major flyover bridge. Here is a bridge and transmitted a load of 4,000 8,400 kilonewton at the foundation level, and the width of the pier is 1 meter is given. Here is the width of the pier, 1 meter, and length of the pier is 9 meter. And hard start soil is available at the depth of 6 meter below of the ground level of the bridge side. Pile bearing capacity is 616 kilonewton, and pile dia is 0339 millimeter, and length of pile is 6.6 meter, and spacing of the pile 1.5 meter, and apparent compressive strength of column is 20 MPa, and yield strength of steel 415 MPa. Design the pile. So let's start the design. At first, and we have to find out the number of piles. We know the number of piles equal to 1.1 dead root plus live load divided by pile bearing capacity, and we will got the 14 pile we have to use, and load on each pile. So we will multiply, we will divide the 14 divided by total load which is applied on piles. We have gotten 600 kilonewton load applied on each of the pile. So 14 piles are arranged at the spacing 1.5 centimeter center to center, as we have shown here in the question, or in a practical field. We have found the width of the pier 1.5 and length of the pier 1.6, and the spacing of piles 1.5 meter. That's why we have arranged this pile in 40, the 7 in the one direction, and another direction is 7. So total we have used 14. Here is the pier. So we have noted that we will not focus on at pile, but we will focus on pile, only for pile, and not pile cap, as we have doing the pile design. So we will not focus this in this pile cap. So we will focus only for pile, because of we will doing the pile design. I will discuss another lecture for pile cap design. So let's see the pile reinforcement. At first we have to find the longitudinal reinforcement. As we know, the pile length is given 6.6 meter, is found from the soil test report, and dia of pile is 339. At first we have assumed that even though the question is given here 339 meter, but we have assumed this, and we will trial and error and find the final dia of the pile. So L is 6.6 meter and dia is 0.339 meter. So the ratio of L by D is 19.47, which is greater than 14, therefore greater than 12. So the pile will be designed as a long column. As F is, if we will get the L by D ratio is less than 12, then we will design the short column. So reduction factor we have noticed is Z, which is 1.25 minus L by D ratio divided by 48, and we have found 0.88. And safe permission stress in concrete, which is Z, we have found in our layer, which is reduction factor into 5, and we have found 4.4 MPa, and another permission stress Z into F', which is compressive strength, and found 15.8 MPa. So let's start the pile design. Before the doing the pile design, we have to ensure that stress equal to force per area. So if we count in the force in left side, then we will show the stress into area. Here is the stress into area. So at first we know the stress will be distributed in concrete, and plus we will be contribute the steel section. So these two section will take the pile forces. One is concrete, another is steel. Okay, so this formula is a basic formula, and here is the main formula of pile or column design. We have shown the PU equal to alpha phi 0.85 FMC AG plus Fy into AST. Here is the concrete part, which is replace ASCE to AG minus AST plus Fy AST. Okay, so we have found the pile load. Here is the pile load. Each pile, the load is each pile, not 14 pile. Each pile is for 600 kilonewton. We have taken is Newton, multiply with 1000, and be of putting the alpha value 0.85 and phi is 0.75, and F prime C 0.85, and F prime C is 15.8. As we have reduced the permissible stress, we have shown earlier the 15 point, we have used 15.8, and that's why we have used 15.8. And the area of the pile, as we have assumed at first, here is a 15.8, and area dia of the pile 339 is given the pile dia here. This is assumed data, as we have already noticed that assume this value, and found the steel ratio, which is found is negative value, negative 673. That's mean the since negative value, so we have to reduce the pile dia. We have already we have assumed the more dia of pile. That's why we will reduce the pile dia. So we again assume the dia of pile 200 millimeter, and putting this value in this equation. So P equal to alpha phi 0.85 FMC AG minus AST plus Fy AST, and alpha equal to P equal to 660 10 to the versus, which is converted to Newton 0.85, and alpha equal to 0.75 and 0.85 in, and F prime C is 15.8. We have already shown why you will use 15.8, because the same permissible stress in concrete, which is 15.8, is found Z into F prime C. Z is reduction factor. Okay, and putting this value, and another we have already putting the changing dia of the pile, which is 200 millimeter, and putting the steel ratio 1294 millimeter square, and we have used that 20 millibar, and the area of 20 millibar is 314 millimeter square. So number of required bar is 1298 divided by 300 millimeters. So we have found 4.12. So as we know, there is the minimum reinforcement of pile or spiral column. It should be a minimum main bar should be 6. That's why we have used the 6. So if you go to the section in code provision, then you have to must be seen the minimum reinforcement 6. There is no other reinforcement less than 6. Okay, this is the code requirement. Okay, so percent of steel bar is AS2 by AS equal to 100, which is found 4.12. As we know, the pile or column, the minimum reinforcement 1 to 6, and we have found 4.12. So this is okay. So 6 milli 6 6 6 number 20 millimeter we have used. So now we will go to lateral reinforcement. We know the core dia of pile we have gotten 200 and minus 2 into 30. 30 is the clear cover. So each two side here is if we go to the section, sorry for um, okay, sorry for the figure. So this is the clear cover of 30 and another portion is 30 milli. That's why we reduce the 30 and found the core dia and core area of concrete which is 15386 millimeter square and row of steel is 0.85 F prime CAG Fy divided by Ag minus AC minus 1 and which is we have found that 0.0228. This is the steel ratio of spiral column. And now we will use 8 millimeter bar as a transverse or lateral reinforcement, and we know the 8 millibar area 15.2 millimeter, it should be millimeter square, and spacing we will use 4 as into rho as into DC is squared core dia of pile. I have earlier described or core dia of pile and found 61 millimeter which is 2.6 inches center to center. Here is the 2.6. So as we know the code provision said that this this reinforcement only provided up to 5D or 1800 millimeter square. This is for code requirement. So we know the our dia of pile is 5 and we have shown the 1050. So we can see the value is okay. So 6 feet we can use this value only up to 6 feet. This is spiral dia or lateral dia, and so now we can say that from the top of the pile to 1800 millimeter which is 6 feet provided to 10 millimeter spiral bar at the rate of 61 millimeter center to center, and the rest of the from 6 feet here is the 6 feet we have calculated this only 6 feet, this 6 feet we have found 2 inches or 61 millimeter center to center. This is the 61. We can call is pitch. We can see the here the picture is pitch. The center from this portion to this portion is called pitch. So this is our calculation, and we have found the from 6 feet. This is the 6 feet from the rest of the column. This is the 6 feet and rest of the column. Spiral bar will use the 5 inches center to center. Here is the 10 millibar spiral at the rate of 125 millimeter or 5 inches center from 72 or 6 feet to the rest of the pile or 4.8 meter. Or we can see this is the main scenario of the pile. We will not design the pile cat as we will design the pile. So this is the first time we will see this is the 5D. We will use the calculated reinforcement, spiral reinforcement, and rest of the portion we will use 5 inches center by center as the economical design. And we also find the minimum main reinforcement in 6 bar is 20 milli, main bar is used in here. Now this is our pile design. Now we can see the code provision. I want to share the BNBC, which is Bangladesh National Building Code. The minimum reinforcement is still for board cast and situ pile is here. Here's the pile dia which is 400 millimeter, but we have designed for 200 millimeter here. As far I know that assume 200 millimeter, and bar size 16 millibar, and minimum number of bar we have to use must be not less than 5, and size of the lateral, this is the lateral reinforcement. or hoops we can see, and this is the main reinforcement. Okay, lateral hoops, they used 8 millibar, which is piece 200 millimeter center center. But we have shown here, we have used the 8 millibar. Here they also use 8 millibar, and we have found 61 inches center by center, 61 into center by center. But they could provide, say, the minimum is 200 millimeters. So this is quite okay. Uh, so this is the pile design, as we know, but we will not use this method, because the code provision already says the use this provision. But I have shown the calculating the pile design, how to design a pile. uh, Thanks for watching this video. I hope you will find something or more from. If you have any question, then let me know. Thank you.